Welcome to another video on ESP32. Today we are going to see how we can use ESP32 to display the current local temperature on TM1637 module. So this is in continuation with the previous video where we have displayed the local from the Wi-Fi time extracting from the network and displaying in TM1637. So in this video we are going to use the same setup. So the key things that you need is the ESP32 Dev Board and TM1637 module along with few connecting wires and a USB cable. Today's setup, we are going to use pin 4 GPIO pin 4 and 5 of ESP32, and we are going to power it by 3.3 volt from the ESP32. So if you can see the respective pins, pin 5 and pin 4. So pin 4 is connected to clock, and so the yellow wire, it's connected to clock, and the DIO, the orange one, is connected to pin 5, and the power is like red one. We are the voltage we are giving 3.3 from ESP32, and the gray color is the ground wire. So before further delay, let's move into the code and see how we are extracting the time and showing it in the TM1637. So we'll use the same code and extend to include the temperature. We will be using the same code which we had in the previous video. We'll see shortly how to update that one. Welcome to the code, and if you can see the Wi-Fi, we have used Wi-Fi.h, time.h, similar to the one which we had used in the earlier video to display the time. And here the two things that is extra is HTTP client and ArduinoJson.h. So we are using two additional libraries in this one, and I will shortly show how to install those two. And as mentioned earlier in the video, so we are connecting the clock pin of TM1637 with the GPIO pin 4 of ESP32, DIO pin with GPIO pin 5. You can use any other GPIO like pin 17 and 18 also will work. VCC to 3.3 volt and ground to ground. Also in this we are going to use weather API. So as a prerequisite, you should have an account at the with weatherapi.com. So it's a straightforward, you can, and it's free, so you can go and create it, and from there you get the API, and we'll be using the weather API URL in our code to fetch the local temperature. So as you can see that we have used HTTP client, so we need to install this library. So right now I have already installed, so that's why you can see the remove option, but you can go ahead from the manage library, search for HTTP client, and you will get HTTP client. Install this particular version by Adrian. So this is the one which I am using. You can use any other library, HTTP client library. There may be some minor change in the methods that is used in that library. So if you are following my code, you install this particular library. Similarly, you need to install ArduinoJson. So if you are following my code again, for the ArduinoJson, you install the one which is by Inuit. So this is we are using the methods from this library. So you are free to use other library. So depending on that, there may be minor change in the methods that it is required. but otherwise it will be fine. So other than these two additional libraries, the other like TM1637 we have installed earlier in my earlier video. I have shown separately. Similarly with the Wi-Fi.h. So if you need any help, you can just watch the other video. I will provide the link in the description for that, so that you will get this idea on how to install Wi-Fi.h Wi-Fi library and the TM1637 display library. So next part is the SSID and password. This is again similar to the previous video, so I'm not going much detail on this too. The new thing over here is this weather API URL. So as I mentioned earlier, you need to have an account with the weather API.com, and from there you will get the API key. Just replace this with the API key that you have, and the location with your location. The URL is straightforward. You need to use this URL, and I am appending the location and the API key with the URL. Next part is, if you see this code, this is to display the centigrade and Fahrenheit symbol in the display module. So this is straightforward and it's hard coded. So because we are displaying this two types of temperature, one is centigrade and another is Fahrenheit. So both symbols we are using in our display. We'll shortly going to see it in the working model. Next, the code in some global variables to calculate the temperature, extract from the JSON and display. Then this is the Wi-Fi connection part. So this we have covered in detail in my previous video, so you can watch over there. The next part is the actual new thing over here, where we are fetching the temperature. So here we are using HTTP client. So we are using this http.begin URL with the URL to fetch the data from that API URL, and we are storing that return value in HTTP code variable. So here, so this we are using the HTTP code to make sure that we are only trying to parse the JSON when the response is success. That is, if the response is 200, we are checking for that. HTTP code OK is response code 200, and only when the response is successful, that is 200, then we are extracting that payload and saving in the payload string file, which we will be using to parse that. So right now I have displayed it in the serial monitor to debug, but you can comment it out once the project is successful. And then using this JSON, the ArduinoJSon parser, we are extracting that and saving it. Like we will be extracting it and showing it in the we will extract the time and showing it in the display module. So if there is any error in deserialization, then it will show it on the serial monitor. Otherwise it will extract the time. So we are using this format. So you can try that URL in the browser and see how the data is returned, and it will be clear. The API returns the data in this format. If you can see my screen here, the location and then latitude, longitude and all details, and then in the section current it will display time, temperature in centigrade, temperature in Fahrenheit, and so on. So you can extract other informations also depending on your need. Right now we are only planning to display these two values. So these two we are extracting, like under the current section header we are extracting temp underscore C and the temp underscore F, that is the Fahrenheit temperature and Celsius temperature. So these two we are storing in these two variable, and below that we are, while displaying it, we are so this display is the display time which we had used in the previous video. So I am not going to explain right now this one, so you can just watch my other video and get the details from there. So the next important thing is the setup part. So before this, in it there are few more things that you should be aware of. First is the last fetch time. So we are using this because we are, and the fetch interval. So right now the fetch interval that I have set is 5 minutes. That is, every 5 minutes it will try to fetch an updated value from the API. So you can increase this time to 1 hour or half an hour, so depending on your need. So right now for this video I have updated it to 5 minutes, and then the last fetch time it will check when was it last fetched. So it will check till 5 minutes, and once the 5-minute time is passed, then it will again call the API URL. So let's go back to the setup. So the first part of the setup is same as for the time, that is the previous video where we are displaying the time. The additional thing is over here. So we are fetching again and updating the temperature during setup. And in the loop part, this I will explain little later, but before first thing that you need to see is this part. So here we are checking the fetch interval, and when the last time that API URL was called and fetched, the temperature was extracted. If it exceeds this fetch interval, that is right now it is set to 5 minutes, you can set it to 1 hour. It will, if it exceeds that, it will again call the URL and store that information. That is the update temperature is called, which will extract the URL, the temperature from the API. And then this last fetch time, it will update with the current time. Next part is just formatting the time that is displayed, that we extracted. So since we want to display it in the TM1637 module, so we are rounding it to decimal place. We are just displaying it, rounding and displaying it so that it is particularly displayed correctly. And we are also, for debugging purpose, displaying it on the serial monitor. So first part is the Celsius, and the second part, this part is for the Fahrenheit temperature. And if you note that I am calling both after a delay of 5 seconds. So first it will display this Celsius temperature, then after next 5 seconds it will display this one, the Fahrenheit temperature. And then so it will start with the display of time. So it will, the time will refresh every second, that is every 1000 milliseconds, which is that every second. And I am calling 5 times because after I'm displaying the time for 5 seconds. So I'm calling this 5 times, and each time it is refreshing, each second it is refreshing. Why I'm using the delay of 1 second is that so that the blinking colon effect is also visible. And so I'm calling this display time 5 times for 5 seconds, and then I'm displaying the Celsius temperature for 5 seconds, next 5 seconds, and then again the Fahrenheit temperature for next further 5 seconds, and then again it will cycle through the time. So it will display time, Celsius temperature and Fahrenheit temperature in loop. So we can see it shortly how the working of this one. I will just update the password and Wi-Fi password and the API key and upload the code, and then we'll come back again. So after compiling and publishing that code into the ESP32 board, so you can see the temperature that it is displaying, Celsius and then the Fahrenheit. So this 5 times time displays every 5 seconds, and the temperature, Celsius temperature, Fahrenheit temperature, and then again the time. So this will cycle through. And before that there was a Wi-Fi connection which is not showing here. I refreshed that screen, so this will cycle through. So let's connect to the, let's see how it looks like on the screen on the module. So you can see the temperature 32 degree Fahrenheit and 90 degree Fahrenheit and 32 degree Celsius, and the time, that is 10:22. It will cycle through. So you can see it is cycling through the temperature on Celsius, Fahrenheit, and then the time every 5 seconds. So few things that you need to keep in mind while working on this project is that the voltage that you need to provide, like the power, you make sure you use 3.3 volt because that is a safe voltage for the module. 5 volt sometimes creates problem. Next is the pin connection, GPIO pin connection. Some boards are not correctly labeled because there are multiple versions of ESP32. So some with pin 36, some with pin 38, and so on. So just make sure that the pin corrections are correct. So that is again a chance of error. And another unique thing is that the libraries. So the library that you are using, make sure you if you are following my code, use the library which I have mentioned earlier. And otherwise, if you are using some other library, you may need to tweak your code slightly to make sure you are calling the correct method. Thank you for watching this video. If you have any doubts, any query, you can just mention it in the comment, and I will try to answer it. Thank you for watching.